Okay, well, thank you very much. I appreciate everybody spending time. I know people's time is valuable, and I'll just say a word about myself because I'm bringing a certain amount of experience into the webinar. I've had about 35 years of experience in reliability engineering and management. For a number of years, I was manager of product reliability at General Motors, had responsibility for FMEAs and design for reliability methods. I've also been, the last 14 or 15 years, I've been teaching and consulting in FMEA and reliability management with over 100 companies. And I share that with you not to tout my resume, but to share with you that's the experience that I want to bring to this, because selecting the right reliability tools is a really important subject. I believe strongly in our field. I participate regularly in RAMs and ARS. And do tutorials along with Fred at those symposiums. And I want to share that experience with you. Uh, I'll share with you candidly about how to select reliability tools. I've certainly in the years back have made mistakes on this, and part of those mistakes are converting that and learning from it. One of my favorite quotes from Oscar Wilde, the Irish poet, is experience is the name people give to their mistakes. So from that, I think we all have some experience to share. A good reliability plan will get you where you need to be from a reliability standpoint. So let's begin. This webinar, I hope to add value to everybody that's participating, whether you're on the product design side or the manufacturing side, or whether you're in field or maintenance, and also whether you're new to reliability or you've been around for many years, like Fred and I have. So let's start with what the objective is here. I'm going to cover with you what a reliability plan is. I'll then add an overview of the steps to achieving high reliability. And that context of achieving high reliability, those steps, will cover today's webinar, and then there's also a follow-up webinar, the second one in this series, which will be a week from tomorrow on Tuesday. Then we're going to go into the specific steps to selecting the right reliability tools, and then how to avoid some of the common pitfalls to reliability tool selection. And feel free at any time during the presentation to raise your hand. Fred will be monitoring. And if you have questions, put them in the chat window. And Fred will interrupt or speak up if there are questions so we can take them up. Or I'll be saving time at the end if you want to ask your questions at the end. So the presentation itself will take up a portion of the hour that we're spending today, but be thinking about your questions as well. Okay, so here we go. So what is a reliability plan? Let's start with the definition of reliability. Textbook definition, reliability is the probability that an item will perform its intended function for a designated period of time without failure under specified conditions. So it really has four things, and Fred and I both teach this a lot, and you'll hear this throughout our webinars and presentations, and I'm sure those of you that are experienced in reliability are aware of it. There's really four things we're talking about. A statistical measure, like a probability statement. Also included in the definition is the intended function, what the item is intended to do. The time frame, and the specified operating and environmental conditions. All four of those are essential to achieving high reliability and the definition of reliability. So then moving on, the definition of plan. Here we go. Oh, go back one. A plan, and this is from a business dictionary, a plan is a written account of intended future course of action. The idea here is to achieve specific goals within a specific time frame, and it includes the who, what, when, where, how, that type of information. So a plan is getting from where you are today to where you need to be. So putting that together, a reliability plan is the entire set of tasks that need to be accomplished, including the responsibility for execution and all the other information that's needed So the objective is to design and manufacture highly reliable products on time and cost effectively. So why are we concerned about reliability plans? Well, one of my American baseball legend Yogi Berra, he said humorously, if you don't know where you're going, you'll end up someplace else. So the idea is to end up where you need to be by using reliability planning. So let me add a couple descriptions then, 2 pages here, of what we mean by reliability plan. You can write a reliability plan at a generic level, which means company-wide, like an overall program or a division. That generic or company-wide or program reliability plan can be tailored to specific projects, or you can start purely at the project level. Like designing a new widget, you could have a reliability plan, or you could have a reliability plan at the widget company. It's a roadmap to move from where you are today to where you need to be from a reliability standpoint. And then some other descriptors, and I'll describe all of these. It includes typically a summarized version of what we call reliability strategic vision, and I'll explain what that is. A reliability gap analysis, and likewise I'll explain what that is, and the full set of tasks. So what I'm trying to say here is that we don't start a reliability plan just by writing out the tools and the tasks. We start the reliability plan with understanding the strategic vision, which includes your reliability objectives, and a gap analysis. So I'll explain that in a little bit, but that's a really important point. And then, of course, each of the tasks should include the timing and responsibility with enough detail to ensure the task is well defined. What we want to avoid is a long list of tasks that exceed resources and capabilities. Okay, so those are some descriptors of a reliability plan. I want to start off because we want to be interactive here. So we've got quite a number of people. And so we're going to have maybe 3, I'll call them quizzes or questions for you. And the first one now, based on what we're talking about a reliability plan or your experience, select one that best describes a reliability plan. 1, a list of reliability tools that will be used. 2, a test plan for the product. 3, the entire set of tasks that need to be accomplished to achieve reliability objectives. 4, a template like MIL Standard 785, or 5, a statement of intent to achieve reliability goals. So take a minute and select one of those 5. And Fred will tally them up and share with you the results.
All right. Well, I mean, it's overwhelming since you just gave it away in the last 2 slides. The number 3 has got 85% of it. A few rogues are out there picking number 5, the intent to achieve a goal.
Okay.
So let me go back to your presentation.
Okay, well, thank you all and that was an easy quiz. So the next one will be a little more challenging. And I understand that some of these 1 to 5s are included, like you may include a list of tools, you might include a statement of intent, but primarily we have the entire set of tasks that need to be accomplished. So well done on that. We'll continue on. I want to share with you that there's a couple of primary disciplines in the field of reliability. One is reliability engineering, where you're concerned about the knowledge and application of the methods to achieve high reliability. And separately is reliability management, which is how to establish and execute reliability programs. And reliability plans draws on and uses both disciplines. So I wanted to scope that out and share that broader scope with you. Underlying philosophy, I always believe it's important to start any discussion with your underlying philosophy. So I want to share 3 things with you. First of all, reliability must be designed into products and processes. It wasn't always that way. I'm thinking back into the 80s, and some of you that have been around for a number of years, you'll remember that a lot of reliability was focused on test and fix. and I call it the test and fix treadmill, where you're working on, um, you develop the prototypes and then you test them and then you fix them as your way to achieve reliability. We learned, particularly in the late 80s and early 90s, that given fast to market and highly competitive cost budgets, you can't really achieve reliability objectives by test and fix alone, and that you really need to focus on design. So that's that first bullet. The second bullet is knowing how to calculate reliability is important. Knowing how to achieve it is more important. When I took over GM's reliability department in the late 1980s, the engineers there were primarily focused on calculating reliability. In fact, their job was, you could summarize their job, which is telling people the reliability number that they need to achieve. And I stepped back and I looked at that and I said, that's not a value added use of time. GM products back then were not as reliable as they should be. And I wanted the reliability engineers to focus on helping design and manufacturing to achieve reliability. So we did a lot of, some of it groundbreaking, some of it moving the ball forward on design for reliability. Lastly, if you want to avoid pushing on a rope as a reliability engineer, reliability practices must be integrated into the overall product development and design processes. So that's some underlying philosophy. This slide, let me tell you a story about this slide. Back in the mid-90s, the Secretary of Defense, William Perry in the United States, had an initiative to convert from military standards that describe reliability to commercial standards. He saw that had more information and better and more up-to-date information, so he started to convert those. And one of them was converting the MIL Standard 785, which is reliability plans, to a commercial standard, which became an SAE, Society of Automotive Engineers, JA 1000 and 1001 guidebook and standard on reliability planning. And in that guidebook was this long list of reliability tools, and this is a snapshot of those tools. And the point that I want to make with this slide is we have a lot of tools in reliability engineering. And a reliability plan needs to select only the most vital and important tools. So the point that we'll make here from that is the key is to select the most effective, or what I'll call the vital few tools that achieve high reliability. Let me go back here. And the story I'll share with you on this one was my first reliability plan. Fred knows this one, and we talk about this in the tutorial, is Carl's first reliability plan was on the Caprice program in 1989 at General Motors. And I was a new reliability engineer on that program. And I only had a couple days to prepare for a big meeting with all of the project managers. And they said, Carl, bring your reliability plan together. Well, knowing what I know now, I wouldn't show up with a reliability plan the way I did. Because what I did back then was listed every reliability tool I could think of and put that into a long sheet of paper and made a presentation from it, which essentially listed tools. And so that was embarrassing, and I learned a big lesson from that is you want to be able to select the vital few tools to be able to achieve your reliability objectives, not a long list of tools that nobody's going to implement. Okay, so continuing on. And of course, it's a mistake to copy a list of reliability tasks or tools from a guidebook such as 785. That's the corollary to that. Now, this slide is titled Primary Steps to Achieving High Reliability. These 5 steps are really important. And the first 3 steps are the subject of this webinar today. Develop a reliability strategic vision, which I'll share with you on the next slide. Perform a gap assessment for reliability, and then select the right reliability tools. Then we create an effective reliability plan, which, let me go back here, which will be the subject of the webinar next week. and then execute, which is also covered next week. So we're going to cover all 5 of these today and next week. And when we talk about reliability tools, Fred and I have different buckets that we consider. You have requirements, tools, and tasks, risk reduction tools and tasks, assurance, and organizational. So that's part of the scope of what we mean when we talk about reliability tools and the subsequent tasks that are part of the reliability plan. Okay, so now we can go to the next slide. Reliability strategic vision. So what do we mean by that? This is more than the reliability numbers. Of course, everyone knows you start with reliability numbers, but I also want to encourage you to understand with your management what the vision is for reliability. On this, the presentation seems to be going forward, Fred, on its own. I'm going to go back to here. Okay, so let me read this, and give me a minute. Reliability strategic vision. We're talking about the infrastructure, the resources, the skills, the methods capability, as well as the number. So it means all of those things, and that I typically like to do by discussing with management as well as employees and understood company-wide as where you want to be in 1 year, 2 years, 3 years, 5 years from resource infrastructure as well as your target values. I'll give you an example. Just these are randomly selected from some reliability plans that include reliability strategic vision. And I'll just read a couple of them, but I included them here for you because you can download and it might be useful to see these examples. So for instance, one company said, system reliability requirements must exceed the benchmark of targeted competition and be converted into design parameters. Another one further on down, that their objective was to reduce warranty costs by 30% over 5 years. So very important to start with what Stephen Covey talks about, begin with the end in mind. Now, a short story here at General Motors, we didn't do this back in the 80s. We did have a vision for reliability to be greater than the competition, but our reliability objectives and reliability numbers did not add up to beating Honda and Toyota. And so that was a lesson learned, that we need to integrate the reliability numbers with the strategic vision, and that's why I always start with that vision statement when doing a reliability plan. Now I want to talk about reliability gap assessment. Here's where, if you start with the understanding of the reliability vision, we can start analyzing the shortcomings, what I call gaps, to achieving the vision. These identify the capability of your current products and processes, as well as the methods. So we're talking about both how well you can achieve reliability objectives, as well as what's the effectiveness of your current reliability methods. And it identifies high-risk areas. So that gap assessment is very important and is part of the input to your reliability plan. So the next slide, I just want to give you an example of, in a minute, give you an example of that, but the reliability gap assessment has outputs. That's a document outlining the shortcomings or gaps between the vision and the current capability. And it also includes strengths. I remember one of my first reliability gap assessments, I just listed out all the shortcomings and I missed out the benefit of identifying the strengths. So that was a lesson learned, to include the strengths as well as the shortcomings. Okay, so here's an example of 2 pages here. For instance, on reliability requirements, excerpted from a real gap, lack of agreed upon definition of failure in the specifications, and the system reliability requirements are not converted into design parameters. That was the one where they had that as a vision. And they had a lack of understanding of system reliability analysis. They were essentially doing it incorrectly. On FMEAs, there was a lack of a consistent approach to the RPN handlings. They didn't use field problems as input to their FMEA, which is really important. and others. So these are examples from a longer document that summarize the reliability gap assessment. And of course, the gap assessment covers the different tools, covers the different methods, as well as the reliability organization, as well as the process. So that's some examples. Now, I'll share with you a story recently. Is I did a reliability gap assessment with a company that was using MTBF, mean time between failure, as the reliability metric on their systems. And as many of you know, Fred and I have taught for years that MTBF is not the best metric to use. Not only were they using MTBF, but they were testing only to warranty time frame as opposed to the product life time frame. And so those were examples of gaps. So when writing the reliability plan, it was important there and important always to know what the vision statement is and what the gaps are so that you can select the right tools to close the gaps. Okay, so at this point, this is a good time to ask another set of questions. And like I say, we're upping the game here a little bit. This time you can have more than one answer. Which of the following are true statements in your opinion about a reliability gap assessment? A, gaps include organizational capability. B, includes a list of tasks that will be done to achieve the reliability objectives. C, assesses the effectiveness of current reliability methods. D, includes the completed system and design FMEAs. And E, begins with an understanding of the vision for reliability. So remember, this is a reliability gap assessment, not a reliability plan. Which of those 5 are true statements in your opinion about a reliability gap assessment? And we'll give a couple of minutes for that.
Right. Hey, Carl, it's looking like 1, 3, and 5 are winning. There's a couple of selections. A couple of people have chosen number 4 on complete system and design FMEAs. I'm not sure if they read your book or not. And they should be broadcast. You should be able to see the results. Carl, are you able to see the results?
Yes, I can see them right now. And cursoring down, 1, 3, and 5, excellent. So we can share back to the presentation now. Thank you very much, and the audience. I really appreciate your interaction there, and you're exactly correct. 1, 3, and 5 are A, C, and D. I'm sorry, A, C, and E are very important statements about reliability gap assessment. So continuing on, so selecting the right reliability tools. I don't know how many of you have read Dr. Juran's books, but he originally began using what's called the Pareto principle, what we often call the 80-20 rule, and where 80% of effects come for 20% of the causes. The reason I share that with you is because that type of approach, where you want to get the vital few tools as opposed to the long list of tools, is more effective than trying to implement every tool that's in the guidebook. Just a short story here for those that you don't know. The Pareto principle came from an economist, Vilfredo Pareto. 1896, he wrote, quote, 20% of pea pods in gardens contain 80% of the peas. And so that's the origin of it. We've, in reliability, we call it the 80-20 rule, and we use it a lot to help us zero in on the right tools, and Juran calls it the Pareto principle. So selecting the right reliability tools, always start with your strategic vision and your reliability gap assessment before you start selecting the tools. In other words, the wrong way is to say, oh, got to do a reliability plan, so let me go right ahead and select the tools. The right way is to always start with those tools first. So be specific on tool description. Don't just say FMEA, say design FMEA on subsystem X. Don't just say DOE, say DOE on some decal application process. Another point that I want to make is if a tool is needed that's beyond the current organizational capability, then you can do one of two things. You can increase the organizational capability, which is preferred, or you can select an alternative tool. For example, if you want to do physics of failure modeling, if that's the tool that you think is needed, but you don't have the organizational capability, because it does take the resources and the software to do that, then you can either hire and train the right people or select an alternative tool. So then what I want to state here is that you want to select tools from different buckets, because you're always going to need requirements tools. I don't know of a reliability plan that doesn't begin with a good statement of reliability requirements. And yet reliability requirements can be based on system reliability modeling. They include generating system conditions of use and operating profiles, flowing down from system to subsystem to component. So there's different tools and tasks that are in that first bucket. The second bucket is risk reduction tasks. They include things like design margin analysis or design FMEAs. They would include things like manufacturing capability if manufacturing's within your scope of the reliability plan, or robust design projects. So that's risk reduction, how you reduce the risk to an acceptable level during product development. Assurance tasks are what we typically think of as testing or analyses. They could include things like developing reliability testing or working with suppliers on their supplier testing. So everything that we consider assurance is in that bucket. And of course, then there's organizational tasks. And there are some other buckets, because you can talk about field and you can talk about maintenance. Of your reliability plan, you want to pull from different types of tools. But remember, you're closing gaps in tool selection. So let me be specific on this. And let's take one example. Let's say from your gap assessment. Remember this one from a few slides ago. Let's say this gap came up during your gap assessment, and you have a lack of agreed upon definition of failure, and you have system reliability requirements not converted into design parameters, and lack of understanding and use of system reliability analysis. So that's in your gap assessment results. What tools can be used to close this gap? And at this point, you can just go ahead and write in your chat window, or however Fred guides you to, because I don't have a multiple choice on this. I just want to get you thinking about the types of tools that you can use to close this gap. So go ahead on this one.
Yeah, and the chat window is the best on this one. So
Okay,
Jim's
good.
going to jump
So
in.
just go ahead and type in some. Yep.
And was it Jim that mentioned he has your book from earlier? I saw that comment
that was
go
Mark.
by. That was Mark.
Mhm.
Okay. And Carl, sorry about the slides. I think when I'm hitting enter on the chat window, it advances the slides. So I think I found a workaround for that.
Okay, that's what's happening. All right, no problem, Fred.
So we got fault tree analysis. Are we at? And so Rosalie's thinking we're on the wrong slide for the question, but this is the three gaps that were identified in that previous slide. And so what Carl's looking for is, what would you recommend would bridge those gaps? Which types of activities or tasks or tools would you select to solve those things? So
these are excellent topics that people are bringing up, and we'll just give a few more minutes. Functional block diagram, someone's writing, fault tree analysis, critical to quality flow down, and others. Okay, so system requirements definition, excellent, fishbone. So very good ideas here. Let me continue on then, and I'll state, because there's no perfect answer to this. This depends on your circumstances, and that's really what I want to say. There is no one size fits all on a reliability plan. Very much depends on the vision for where you're going, your reliability requirements, and your gap assessment. So in this case, we might have some types of, you might have a task or a tool like reliability requirements definition, system reliability analysis, and other ones like you're mentioning. So you want to carefully think about the gaps that you have from that gap assessment and select the tools to close the gaps. They could be organizational gaps, they could be methods gaps, they could be risk gaps. What are the tools to close the gaps and achieve your reliability objectives? So that's the important takeaway, one of the important takeaways from this webinar. So let me continue on then. So once you have the tools identified, so you've done all this work to do your gap assessment and you've got the tools identified, we then move on to creating the reliability plan. This will be expanded on next week because there's a lot of important information to share with you about how to move from a list of tools to an actual plan that can be executed easily and get to the reliability results that you're looking for. But just summarizing in one slide, this establishes the strategy and actions to achieve your strategic vision, the specific tasks. So at this point, we're moving from tools like FMEA is a tool to tasks like train people on FMEA, hire some FMEA engineers, do a preliminary risk assessment to identify which FMEAs you're going to do. Those are tasks. And that's what we want to get into the reliability plan. We're going to pull together all the necessary resources that are needed. So you might have to do certain organizational things about your reliability groups. You might have to hire some new people. We want to address in the plan the high-risk areas. That's why I always want to have in high-risk areas identified as part of the gaps. Clearly, we're going to strengthen the organizational shortfalls. And then a very important part of the reliability plan is the tasks at the detail level of what, who, when, where, how. So all of that will be the subject of the webinar for creating effective reliability plans. Continuing on. Execution. Wow, what's more important than execution? Once you got the plan, how many times have you written a plan and not executed it? And that happens to companies. One of my favorite quotes on execution is from Leonardo da Vinci. Quote, "I've been impressed with the urgency of doing. Knowing is not enough, we must apply. Being willing is not enough, we must do." Unquote. So Leonardo was on to something. He was tired of people just expressing what they know and was encouraging the application and the doingness. So execution, where you leverage your management. One of the common mistakes in reliability is to try to push on a rope where the reliability engineer becomes responsible for reliability. No, the organization, the company is responsible for quality and reliability. That's the important issue. So we want to leverage the management. And then, of course, all the gaps are closed and the reliability objectives are achieved. I like to see the plan not only be approved by management, but management's involved in the execution on a regular basis. We'll cover the details of that next week. A couple of case studies. The first one is this. Of course, the one pager there, you can read it, but let me tell you the story that goes with this. I went into this company on their request, like I do a lot of companies, and I always walk in and introduce myself to the management and talk with them for a bit because I need management support. I was told they had reliability plans, but they were not effective. And so I asked them about that, and I said, "How are your reliability plans developed?" I asked the management. And the highest level VP opened the open door, and he said, "He's down the hall on the left." That was the answer to how the reliability plans are developed. So I knew at that point that we had some challenges to overcome. So I walked down the hall to the left, walked into the cubicle. One person was sitting there, and I asked that individual, how do you develop a reliability plan? And he pulled out a copy of Mill Standard 785, which is basically a compendium of tools as well as some advices. And he had copy pasted the tools from 785, and that was the reliability plan. So that's the wrong way to do it. What are the two errors there? The first error is you want the management to be involved in the development of the reliability plan, not just the reliability engineer. And you don't want to just copy paste a list of tools. So I met with the management, we discussed their roles in reliability planning, and together with the organization, we did a reliability gap assessment. I went about, as I always do in a gap assessment, to a series of questions and answers with individuals. I talked with them to challenge them about their tools and tasks. Let me give you an example of that. When I'm interviewing people in a gap assessment, always do open questions that lead to more than one-word answers. I try to be curious, interested, engaged, always try to dig deeper. And when talking about methods, I say, to what extent do you use that method? How do you use it? Why do you use it? What examples do you have that demonstrate that use? So you really want to dig in and understand what the company's currently doing, what their existing situation is when you're doing that gap assessment. So with that company on this case study one, we got a good gap assessment and got a good plan, but the lesson learned there is always begin reliability planning with management input and support. The second case study I've already shared with you, which is the wrong way to do it, where I developed my very first reliability plan by a long list of reliability tools on the Caprice program, and I've never done that since, but that was a good lesson learned. Okay, then summarizing, and then I hope you're thinking of questions, because I want to get some questions. I've left time here for questions. So be thinking about those questions, start writing them to Fred, and then Fred, maybe you can summarize those. As I'm summarizing the lessons learned, please enter any questions you have. Ask anything at all. This is very candid, this is very friendly. We're not expecting you to know everything. So ask questions that are challenging about tool selection. The first lesson learned is focus on the vital few. That's the Pareto principle. And the Pareto principle, you want to avoid inclusion of too many. Second thing is I'll call the factor of 10 rule. Let me explain that. The earlier changes are made to designs and processes, the less costly. So you could make changes during concept development, during the product development, during assurance. You could make changes during different stages of product development. And the later you are, the more expensive they are to make changes. And they often go by a factor of 10 in terms of how expensive they are. So earlier the better on tool selection, because you want to have time to implement the tools. The third lesson learned here of 5 is emphasize DFR strategies. So we want to, because of that underlying philosophy that I talked about, you cannot achieve reliability purely by testing. You have to do a balance of design for reliability as well as good reliability assurance. Fourth one, and this one is very important, is be aware that safety always comes first. If you have a reliability objective for your widget system of 95% reliability, that does not mean you're allowing 5% safety problems. That means you're allowing 5% performance problems, 5% reliability problems. Safety is the highest priority and to be considered the same as a performance type issue. So that I think should be self-evident, but I wanted to mention it. And then lastly is always do the reliability gap assessment. Let me just clear that slide up a second. Always do the gap assessment when developing new reliability plans. Don't start with a list of tools. Start with the vision and the gaps, and then select the tools to close the gaps. This is particularly important when you have new technology or new applications. Your companies, remember, have varying abilities to implement reliability tasks, and you want to consider tailoring your reliability plan, the tasks of that plan, to the organization's reliability maturity level. And I'm basically introducing you to that topic because that is a topic that is a subject of a different webinar, a different aspect of reliability, is the reliability maturity level. I'll reference here Philip Crosby's book, Quality is Free. Every company can be placed on its maturity level. In other words, some companies are brand new to reliability, others are very experienced and very capable. If you know where they are on the maturity level, it helps you to identify tasks, and the reliability gap assessment will get you to the maturity level of your company. So that completes the body of the webinar. We have considerably more information we could share, but I wanted to do it within a 45 minutes so we have time for questions. I'll just summarize here. Developing and executing effective reliability plans is essential to achieving high reliability, and I'm hoping that this tutorial you gain some information about how to select the right reliability tools to support your plan. So Fred, let me bounce it back to you, see if we have any questions that have come up from the audience. And I'm going to encourage you, if you haven't, please go ahead and ask questions.
Carl, we've got one
Over to you,
from
Fred.
William, and I'll just summarize it here. He's looking, apparently he's got a project manager or management team that needs to understand the importance of scheduling the reliability activities and getting them into essentially the program schedule or the project schedule. Any tips or ideas on how to get that across, that the reliability activities also need to be included in those schedules?
Excellent, and William, that's a great point as well as question. And I agree with the point there is that reliability needs to be part of the program schedule or the project schedule. I'll go back to when I worked at General Motors, and I had a good relationship, for example, with the chief engineer of the Corvette program, as well as the Impala program and other programs. And when we had reliability activities that were needed, such as improving certain tests, or HALT projects, or FMEAs, or reliability requirements, allocation, I would always interface on a regular basis with the chief engineer and the project team. I would show up at their meetings and thereby get the reliability tasks that we saw that were needed into the schedule. The other way I've done this is I want to get the reliability plan approved by management. You don't want to have the not invented here syndrome. So the reliability management or the program and project management should approve the reliability plan. And that way they can incorporate the tasks into their schedules. So the best way I can answer that, William, is for you to spend time to interface with your reliability and engineering management, so that any reliability plans that you put forward are approved and thereby scheduled into the activities. So if anybody has any follow-ups, please do it. I'll say one more thing, which is a word about reliability requirements. Back in the 80s, we used to have at GM what I'll call reliability goals. They were fluffy, kind of soft reliability goals. Then they would become memos into the program and projects. So you might have a memo in the Silverado project, and that memo said what the reliability goal was. I learned because that was not really meaningful to the design engineers. I wanted to get reliability characterized, not as just a number, but also including the intended functions, the conditions of use, the time frame per definition of reliability, and get that all into the reliability specifications. so that the design engineer could work from reliability requirements and specifications. They weren't just goals, they were requirements, and they needed to be done before product launch. So those are a couple comments about getting your tasks into schedules. Fred, let me turn it back to you. You're monitoring the chat window. Are there any other
I'm going to bring
questions that
up,
people have?
well, I changed the screen so that you have access to the slides, and there's links in the lower right-hand corner that have
Okay,
a
good.
link to Carl's Effective FMEAs, his book site, and a handful of other links and additional information there. One of the questions, Carl, is, I mean, just talking to him and participating with your management team and getting approval doesn't always guarantee that it's part of the plan. I mean, just attending the meetings and showing them the plan. I've gotten that before where they just say, oh, here you go. Yeah, that's approved. That looks good. But then there's no resources behind it. There's no buy-in. Um, how would you go after that?
Okay, great question. I want to go beyond the head nods, and each task, we're going to cover this next week. Each task has a person responsible, a time frame, and resources attached to it. And the management review is not just the head nod, it's approving the budget, the timing, the person, the resources for each task. So when I'm in that meeting presenting a reliability plan, if I say we're going to do a design margin analysis on the widget, I will include who is going to do it, when it's got to be done, the resources or software that's needed, the anything else that has to be approved so that it essentially can be scheduled. So I think the best answer to that is to get down to that level of detail when you get that approval. So it's not just a
Yeah,
head
I
nod.
agree, Carl. I would say that you'd
I'm
also
seeing,
need to say, well, what's in it for them? What's the benefit of this activity? I mean, you did the gap analysis earlier, yet if you say do an FMEA, a design FMEA, and you lay out the details that would go into a plan, it's to what effect? What's the benefit of doing that for the management team to understand why we're doing it? Is that part of those discussions?
excellent, excellent, Fred. And of course, management understands the language of money. And so if you're really good, you can talk about the translation of the task into results, into lower warranty, into lower field incidents, faster development time, and talk specifically about how that improves the
Okay.
financial picture.
We've got
I'm seeing I'm looking at Adam where he said, can you briefly talk about available DFR tools? And yes,
And I want to
we
read
can definitely do
the
that.
call to action
The
we've got, and I think I fixed the link on it. We'll mention that
Okay,
here
good,
before we end, but there's a number of other questions coming up. You got Adam and Yi and Andrew all have questions.
great. So you've got, Fred, you're bringing up the Reliability Engineering Management book that you and I are co-authoring. Fred and I have been working on this for a while. We share very similar philosophies about reliability in design and the importance of using the right tools. And we're going to expand on all this information in this book. And we're making available to anyone that's interested the first chapter for no cost. All we're asking to do, since this book is under development, is that you provide feedback on the first chapter, the second chapter. So you'll essentially get this book for no charge, and that all we request is that you provide feedback on those draft chapters, and that's the request.
Yeah,
Does
it
that
does.
summarize it pretty well,
We've
Fred?
got the chat window and question tab there. So in one, I think a reason I brought this up, Carl, is that in chapter 3, which is a small book in and of itself at the moment, which we hope to get posted to the site for review in a couple of weeks, um, includes a lot of tools. And one of the ideas is that FMEA by itself is worth whole books, as you well know with Carl's work. Yet when and why you would use it and where does it provide a benefit is part of what we're aiming at in the text. And Carl, I don't know how many tools we've got listed in there. I think
Each
it's well over 50.
well over 50. And of course, each tool has a reason, has a description. It has what it's intended to do, what the limitations are of the tool, the selection criteria. That's all important. And let me then expand on the question from, can we go back to that larger window, Fred?
Back to the conclusion.
So I can see the
I don't know if
chats.
it doesn't get any bigger. I don't have control over
Yes,
the
that's
fonts of
perfect.
that. I've asked for that a couple of times. But one of the questions that came up,
Mhm.
and uh, well, there's Andrew's question I'm going to get to in a moment, but there was another one. I mean, talking about the different design for reliability tools. I want to jump in here, Carl, in that things like derating and stress strength analysis and simulation tools looking at loads, um, the different engineering level tools, but that also includes how do you pick a material or a component. And FMEA is certainly involved in the design for reliability world. Those are more often and more effectively done by the engineering teams with the support of reliability professionals. I think that a real bad case is where you list all these tools and then you do it yourself and it doesn't get incorporated into the design itself. And so derating, for example, is the classic tool that your electrical engineering team needs to understand and use. And you can provide guidelines and derating manuals, for example. Uh, but there's a lot of tools that other people in the organization need to do. Now, one question on that, Carl, is in all of this gap analysis, would you include the marketing material and marketing team in that gap analysis?
Yes, you can. I've done that a number of times. It depends on how mature the marketing is influencing the reliability capability. It often is, and so the that's going to be a sometimes yes
Yeah, especially if they're
answer in my
using
opinion.
MTBF, you want to get them out of that. Uh, uh,
Absolutely true. Let me just say another word on uh, the question about let's see if I can get it back. Available DFR tools. Uh, the those buckets that Fred and I talk about, we will list in the book more details, but you can have on DFR, design margin analysis is an example, design FMEAs is an example, uh, root causing known reliability problems is part of it, uh, design guides can be part of DFR, reliability input to design reviews. I even consider HALT uh, as part of the development process, and that can be a very important part of achieving robust designs, as is design of experience, design of experiments, or physics of failure modeling. There's a whole set of tools on DFR. And so, Adam, I just want to expand on that a little bit. I see we have 6 minutes left, so let me look at Yi's question. Um, reliability engineer is kind of TPM, total project management, to control its process, not by preventative maintenance. I think that's what
program manager
he is
in the
saying.
context of that.
Program manager, not by program manager, and TPM
Total
stands
project
for?
management, I believe, or process maintenance.
Yep,
I'm not
yep.
sure. You will have to come back with that. I
Yeah, so Yi, if you could
yeah, I think it's
expand on that one.
technical project
Let me just
manager.
look for.
Yeah, TPM seems to have a lot of
Mhm.
different variants of that. Now, part of it is the
Yes,
is that the reliability engineers, I mean, we take on so many different roles, yet the program manager, in most cases, the technical program manager, is the one that controls the resources. And so you become an aide or an assistant or an advisor or coach even to that project manager in things relating to reliability, right? So it's a lever for you to get more people committed to and getting the resources and timing and scheduling for the reliability activities. Yeah, and certainly you're going to have to roll up your sleeves at some points and go make things happen. Yet it's going to be under the auspices of that technical program manager.
Yeah, and of course the scope of reliability is important. I've been in some companies where they've got a quality department completely separate from a reliability department, completely separate from a safety department,
And they,
and they appear to have
yeah,
these
and then they
rigid lines between them. And I've
So
always go ahead.
there's another
Go
couple
ahead.
of questions here, and we've got a few minutes. Where did it go?
Okay.
Larry had a great question. I'm sorry, Larry. There it is. So how do you convince management that one tool, quality functional deployment, QFD, does not work in all situations?
Oh, great. Yeah, the sometimes you get management that has I'll call it a hobby horse, something that they uh, I remember this a number of years back. One company said, "Oh, we're just going to do Taguchi projects." That was the tool of the program of the month, so to speak, and we're going to implement Taguchi projects across the way. And some other management might say, "We're always going to do QFD." Each tool has a reason to be under select circumstances. You do not always do FMEA in all circumstances. You do not always do QFD. So you have to understand, first of all, yourself, uh, in response to Larry's very good question. You have to understand what the tool is, when it's used, what are the selection criteria, and then go about using it when it's necessary. And I would have one-on-one conversations with management. Never want to embarrass someone in front of a group as to why you don't use one tool
Yeah,
all the
and one
time.
of the hazards is that if you've got benefit from the tool in the past, that was for that particular circumstances, and it may not apply as your organization changes, as the needs change, and so on. So it goes back to the gap analysis. Now, Andrew asks a question that there's tons of templates out there for reliability plans, and I think Carl, you mentioned the 785, and there's others. But is there a template assessments? And he mentions where's a good place to start to do if an organization's not.
I wish there, I wish there was and that's one of the reasons Fred and I are writing this book, and that I'm not just trying to push the book. There was nothing out there on reliability gap assessments. So we have a chapter in detail how to do a reliability gap assessment, what types of questions to ask, what the how to get to the depth that you need to get the gaps identified, examples of gaps. Fred and I take 3 examples of bicycles, different types of bicycle companies, and we carry the examples in the 3 different scenarios. So we have lots of examples. So there is nothing out there that I know of, and there should be,
Yeah, and Andrew,
and we're
you
trying to
mentioned
fill
the
that gap.
IEEE 1624, and I happen to work on that standard and contributed quite a bit to it. It outlines a maturity model, and it talks about that you need to compare the organization to where they are in the maturity matrix. Yet they don't go into depth about how to be really good at doing that. Part of that is, I think, folks at CALS want you to go hire them to do the assessment or hire somebody else to do it. And both Carl and I do that kind of work. Yet we found that organizations certainly can do this themselves, and that's why we're putting that into a central piece of the book.
Fred, in the final minute here, let me look at Karen's question. If you were training project management in DFR, what would you start with? At what level do they need to understand the tool set? I always try to do an overview of DFR with management. They don't necessarily need to understand the details of each tool. They need to know an overview of the tools of DFR, the benefits, like Fred said, the benefits particularly converted into cost benefits and safety benefits, and the selection criteria for the tools. And so that's the level that I go with management. I don't try to go too deep. I don't try to teach them the full training materials on
So
each
one
tool.
more question, Carl, if you've got just
And
is
go ahead.
Bart asked the question, the difference between gap assessment and maturity assessment as if with the AIAG standard. I think that's on maturity assessment.
Yes, and I think a well-done gap assessment will get you the information that you need to conduct a maturity assessment. And that's the way I would characterize the best answer. If you've done a really good vision statement and gap assessment, and including the organizational gaps as well as the method gaps, that you should have the information where you can do a maturity assessment and be able to place an organization on the maturity matrix.
And I'm going to address Thomas's question. He asked about the GEIA standard 009. And it's like the old 785, Mill Standard 785, which is a long list of tools. It also provides, like the 785 did, a list of, well, when and why would you want to use this? So it's the hazard is that too many people just say, do what's in this new standard. And that's not the idea, is it really needs to be a thought through process. And Carl just went through the gap assessment idea of picking the right tools for your particular circumstance. There isn't a one size fits all. There isn't a universal reliability plan that will be effective for you. And that's the whole point. These standards list and these other templates list a world of all the options that are available to us. And a truly mature reliability program uses the tools that add the most value, that are the most effective for a particular circumstance. And that's the whole key, is making sure that it answers the question, will get the results in time, will be a cost-effective return on the investment of doing it. And so plenty of...
Fred has put the my email address on that last slide. If there's any follow-up questions that people have, please do not hesitate to write me. I will be glad to reply and answer in as detail as you like. And that about finishes it. Does that wrap it up, Fred?
I'll stay on the line, Carl, if you're welcome to stay on the line. I'm going to end the recording. And one more plug for that. Carl's got his book out there, Effective FMEAs. We're working on a new one. And you can see the link in the chat window to sign up for that. It's free. You'll get access to the first chapter. Good comments and feedback on that. It'll encourage us to finish the rounds of editing we're doing in writing for the remaining 8, 9, I think we're up to 12 chapters now, Carl. But it's growing, and yep. We appreciate all the input and feedback from everybody, and we'll see you next.
And Dale asks when the slides are available.
Right, under a pod that's called Download the Slides and Papers right here, and I'll have the slides, recording, and all that stuff up Excellent. On reliability.fm probably tonight before I get those posted.